Charles Dalziel, a professor of electrical engineering at the University of California, invented the ground fault circuit interrupter, commonly known as the GFCI, in 1961. The GFCI is a crucial safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing in a circuit. If it detects an imbalance indicating that current is leaking to ground, it quickly shuts off the power. This rapid interruption of the electrical supply can prevent serious injury or even death. To understand the significance of the GFCI, it is important to consider the dangers of electrical shock. When electricity flows through the human body, it can disrupt normal bodily functions, leading to muscle contractions, burns, and cardiac arrest. The severity of the shock depends on several factors, including the amount of current, the path of the current through the body, and the duration of the exposure. Ground faults are a common cause of electrical shock. A ground fault occurs when electrical current unintentionally flows to ground through a path other than the intended circuit. This can happen when a damaged appliance comes into contact with a grounded surface, such as a metal water pipe or a damp floor. In such cases, a person who touches the appliance could become part of the ground fault path, resulting in an electrical shock. Before the invention of the GFCI, the primary means of protection against electrical shock was the fuse or circuit breaker. These devices are designed to protect equipment and wiring from overcurrents such as short circuits. While fuses and circuit breakers can help prevent fires, they are not always effective in preventing electrical shock. This is because they typically do not trip until the current reaches a relatively high level, which may be sufficient to cause serious injury or death. The GFCI offers a much more sensitive and rapid response to ground faults. It is designed to trip when the current imbalance reaches a level as low as 5 milliamps. This is a very small amount of current, but it is enough to cause a painful shock. By tripping quickly, typically within 25 milliseconds, the GFCI can prevent the shock from becoming dangerous. The operation of a GFCI relies on the principle of differential current sensing. The device monitors the current flowing in the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing in the hot wire should be equal to the current flowing in the neutral wire. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral currents. The GFCI detects this imbalance and trips the circuit. There are two main types of GFCIs commonly used. Firstly, receptacle-type GFCIs, which are installed in place of standard electrical outlets, and secondly, circuit breaker-type GFCIs, which are installed in the electrical panel. Receptacle-type GFCIs are typically used in areas where ground faults are more likely to occur, such as bathrooms, kitchens, and outdoor locations. Circuit breaker-type GFCIs provide protection for the entire circuit and are often used for branch circuits that serve multiple outlets. The National Electrical Code, or NEC, requires GFCIs in many locations to enhance electrical safety. Some of the locations where GFCIs are typically required include bathrooms, garages, outdoor receptacles, kitchens, crawl spaces, unfinished basements, boathouses, and within 6 feet of sinks. This requirement is intended to protect people from electrical shock in areas where they are more likely to come into contact with water or grounded surfaces. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. Compliance with the NEC is essential for ensuring the safety of electrical systems. To test a GFCI, there is a Test and Reset button on the GFCI. Pressing the test button simulates a ground fault, causing the GFCI to trip and cut off the power to the circuit. To restore power, the Reset button must be pressed. It is recommended to test GFCIs monthly to ensure that they are functioning properly. GFCIs have significantly reduced the number of electrical shock injuries and fatalities. They are an essential safety device that should be installed and maintained in all homes and businesses. It is important to understand how GFCIs work and to test them regularly to ensure that they are providing adequate protection. The invention of the GFCI was a major breakthrough in electrical safety. Charles Dalziel's contribution has saved countless lives and has made a significant impact on the electrical industry.